Okay, today I'm just going to look at two example questions that deal with combinations. So we already started this last week. Now I went into it, I talked more about combinations in 4.5 than what the book wanted or had put in there. So a couple things. First of all, NCR, again, is order important when we're doing combinations? No, order is not important. We're just choosing n amount or r amount of objects from n. So we don't need to have them in order. So that's the same as the permutation part. I add in this right here for the combination. So this r factorial essentially is dividing by the number of ways in which I arrange the r. That's what that is. That's how come there's a difference between combination and permutation. Another way to write it is this. Those mean the same thing. Okay, this workbook works with NCR in which you have a bracket, n over r bracket, which just means the exact same thing as NCR. It's just a different,
Mr. Wilson, could you call 15,000, please?
just a different notation. Example 1. How many subcommittees of 4 students can be formed from a student council consisting of 7 students? So because they do not specify a position, therefore it's combination. So how many students are there total?
7.
And how many are we choosing from those 7? 4. So that is 7 factorial over 3 factorial, 4 factorial, right? The 3 factorial comes from 7 subtract 4. 4 factorial is you pick 4. We have to divide by the number of ways in which we arrange them. So this works out to 7 times 6 times 5 over 3 times 2 times 1. Those cancel, I'm left with 35 ways in which that happens. Okay? All right, so we did some of this last week. All right. Where this gets into a little more work is the next example in which we are taking from a select group and we might specify boys and girls. All right? These are the more likely questions that you'll see on the exam using combinations, these ones that are next here. At Karina's birthday party, there are 7 boys and 9 girls. Karina has to choose 6 children to start off a party game, including at least 1 boy and at least 1 girl. In how many ways can she do this? All right. So there are a number of ways in which we can do this. Let's just talk about first before I go into it. What is the total number of ways in which I can select in this situation? I'm selecting how many at this birthday party? How many are for this party game? 6 for this party game, and how many kids are there total? 16. So that's the first thing that I'm going to find here. I want to know how many ways I can actually select 6 from 16. Okay, so we're going to use our calculators for this, so take them out. Find out what 16C6 is.
You said it doesn't matter if you put 6 or first, like...
Yes, yeah, it has to be 16 first. Your large number has to go first every time.
Why is that? Why? Explain why.
Okay, it actually explains it in the box above.
Okay.
It says that 0 has to be less than r, and r has to be less than or equal to n. Because you can't pick more than what you already have, right? I can't select 6 from 5. Yeah, so it has to be the larger one first. What did you get as a value?
8,008.
8,008. So if I asked you, how many ways can we select 6 kids from 16? There'd be 8,008 ways in which we can do this. Order, again, is not important. All right. Now, I need a committee of 6. So what I want to look at are, what are all the scenarios in this case? Boys to girls. Okay? So let's look at the scenarios that happen here. Now this one, I don't want you to write this down because this is going to look like a lot of work. But what are the possibilities? The first thing it does specify, though, is it says, I must have at least 1 boy and at least 1 girl. Right? So give me one scenario that can happen then.
One boy, 5 girls.
1 boy, 5 girls. Let's keep going then. 2, 4, right? 3, 3, 4, 2, 5, 1. That's how many ways I can select 6 kids for this party game. So if I were to do this the long way, all right, I'm going to show you an easier way to do this. If I was to do this the long way, all right, I would end up with, okay, how many boys are there total at this party?
Oh no, 7, sorry.
7 boys. So I'd have to go 7C1 times 9C5. And then I'd have to go 7C2, 9C4, 7C3, 9C3, 7C2, 9C, oh sorry, that should be a 4, 4, 2, and then 7C5, 9C1. There are all the possibilities of selecting this group of 6 in which I have at least 1 boy or 1 girl. So you would have to punch all of these into your calculator. You multiply those all the way down, and then you would add them at the very bottom. And that would give you your correct answer. Okay? But I said, there is an easier way in which I can do this. Now, this is going to happen. You're going to use this a lot more in the pre-calculus class when we look at terms and comps. When they use the word at least, let me do this a little bit different. What are the 2 possibilities that I don't have here?
0 and 6.
0 and 6 and 6 and 0. Agreed? So if there's only 2 possibilities that it cannot happen, then maybe what I want to do is take a look at this and take the total number of ways that it can, or the total number of ways that it happens, and if I subtract the 2 ways in which it does not happen, I should end up with the same answer as this right here. And it's a lot easier. So what I do is I go 8008 minus, just a bit.
I can't.
Let's move up.
Oh, sorry.
Somebody watching, it's going to be going back and forth like this. Okay. All right. So let's take the number of ways in which it can happen. So that would be 7C0 times 9C6, right? And 7C6 times 9C0. Okay, now you can use your calculators. So put that into your calculator. So I have 8,008, which again is 16C6, right? Subtract. Just a second.
7 is 0, right?
What is 7C0?
1, 0, 1.
1. There's only one way I can pick nobody, right? Remember, you can't have anything less than 1 in factorials, right?
Is that a times between 7
Yes, it
and
is.
0?
Yeah. So basically what you're doing here, using your logic, making it simpler for yourself, this is what you're doing on your calculator. You don't need 7C0 or 9C0 because that is equal to 1. There's only one way in which you pick none of those boys or none of those girls. So 8,008, subtract 9C6, subtract 7C6. Do we get that as our answer?
Yep.
Yeah?
Yeah.
Perfect. So when they ask you or they give you a specific direction in which they say at least, most times I'm going to use the total subtract the way it can't happen.
I did not.
Did not get that?
You got 77.
you need to add that to 7C6. Okay, so you get 91 there, but you gotta take 8,008, subtract that answer. So, yeah, you didn't do this part. You did this and you did this, but you didn't do that.
But you just plussed it.
I added this and this together, and then subtracted it from that.
Okay,
Does that make sense? So what I did on your calculator is this, basically.
yeah, I got that.
Okay.
Okay.
All right? Okay. That's it for combinations. 4, 6. You were to do 4, 4, and 4, 5 on Friday. I know a number of you are awake, but that means that should have been homework for you. So what do we see? Do we have difficulties with any of this 4, 4, 4, 5? Any questions from it? Number 6 on page 102? Okay, Gareth works at a video rental store. He has 6 copies each of 3 different new DVD releases to put on a shelf. In how many different ways can he arrange the DVDs on the shelf? How did you do it?
That's the only one I got wrong. Like, but I didn't, like, I got it right. I didn't do it. It was
What'd you
wrong.
say, Rory?
It doesn't matter which way you put it. It's not, but you can-
6 copies
Yeah.
of 3 different DVDs. Everybody else do that?
It's not saying you can't put it one beside another.
How can you distinguish the difference between them? They're the same movie, right?
6 copies each of 3 different new DVDs.
So each copy has 2, or each movie has 2 copies?
6 copies.
Yeah. It's
Oh.
6 copies of each.
So you're talking 18 DVDs. Are you not?
I thought, yes, 3 different,
Garrett works at a video rental store.
Okay,
He
so
has
he has
6
3 different
copies
movies.
each.
yeah, he has 18.
So he has 18 different movies, right? So if they were all different, let's say you put a color code on them, you'd have 18 factorial ways of doing that, correct? Right? If there were 18 different movies and you were to line them up, 18, 17, 16, right? But you can't tell the difference between each movie.
Oh my
And
god.
then they have this- You pick up a movie, Kate's or whatever, it's not like-
The first question doesn't have like any specific order to put
He
them.
doesn't
It's
have
the same
any
order.
restrictions, so why can't he just slap them on the shelf? So then it has different, it's like a combination, you know? It doesn't have a specific order, it doesn't have a specific, anything like that.
But you have similar looking DVD covers, so you can't tell the difference between them.
It does not say there's any.
But you have 6.
You have
Yeah.
6 copies of
Oh,
the
yeah,
same
yeah.
DVD, right?
Yeah, but
You follow or no?
no, that's not it.
Okay, you have
Yes.
6 copies of this book
Yes, I
on the
got
back
that.
shelf. Can I distinguish between
Each book,
each book?
no, but
No. So that's the same thing,
Okay.
right? So you can't tell. Now, if they were different, like if you labeled each one, let's say A, B, C, D, E, F, right?
Yeah.
Then I have 18 factorial ways in which I can do it. But because 6 copies of each of them, they're the same. So I treat it like it's like
Okay.
a like permutation in that case.
Okay.
Okay? In how many different ways can DVDs be arranged if the copies of each one must be grouped together? Okay. So I still have this here, right? But I have 3 groups now. So I also have 3 factorial ways in which I can arrange the 6 of them, or the 3 sets. So now I put them into sets. Okay? So movie A, movie B, and movie C, and all 6 copies are in there. Okay? So there's a 3 factorial way in which I can arrange those 3 sets of movies. Okay? Okay. You good?
Yeah, I just did it.
Okay. Go ahead, Morgan.
I know, I'm a little confused, like, they asked certain questions, like with number 6. The people who asked you kind of knew what was going on. I don't know what's going on with number 6. I got B right. I got 6 on B. I took 4,320 divided by 720 and got 6. And pretty much what I was doing was trying everything under the sun to get answers. And I only got an answer for B and 6. And A, I don't know what I'm doing.
Well, A is like 17,153. 17,153,136. I think, yeah, that's what you get.
18 factorial over 6 factorial, 6 factorial, 6 factorial.
I didn't think of that at all.
Okay. Let me do this different. Morgan. Okay. Morgan, you remember this example here. How many ways can I arrange these letters? How many ways can you arrange the 4 letters here?
4 times.
How many?
4.
No. How many decisions do I have to make?
4.
How many options do I have for the first one? How many letters do I have to choose from?
4.
And then you picked one, now how many do you have to choose?
3.
Pick 2, how many?
1.
So the answer is 4 factorial, right?
Yeah. I did that.
You get that?
Mm-hmm.
Is it the same for this one?
Not really, no. There are 4,
Factorial?
yeah.
But
The E, there's 2 E's. There's that changes it.
that's right. So it becomes 4 factorial over 2 factorial.
Yeah.
That's the exact same thing with that question. You have 18 movies, all right?
Yeah.
So there'd be 18 ways in which you can arrange them, but 6 of them are, you've got 3 sets of 6. So you've got 3 different movies, but there's 6 copies of each.
Yeah.
So you can't distinguish the difference between each movie. So movie A has 6 copies. They're all the same. Movie B has 6 copies. They're all the same. And movie C has 6 copies. They're all the same. So you can't tell the difference when you, so think of it, you're going to a movie store. Oh, you don't do that anymore.
Long time ago.
Long time ago. So you go into the library. Look at my back shelf right now. Take a look right behind you.
I've been to the bookstore.
Okay, well, but the bookstore doesn't work the same either because you don't have really necessarily have multiple copies of something. But if you look on my back shelf there, right, you see that there's multiple copies of different books.
Yeah.
Okay, so if I asked you to arrange them, if I took a pile of 4 books, 4 books, and 4 books up and said, okay, arrange them in order. So you have 12 books to arrange in order. But the 4 books look the same that are the same on that shelf, right?
Right.
So that's not a new order then, is it?
No.
So I have to divide by the number of ways in which I can arrange the 4 books themselves. In this case, the 6 movies themselves.
Yeah.
So if I'm looking directly at a shelf of 18 movies, and 6 are the same, and 6 are the same, and 6 are the same, I can't tell if I take one out and put it in, I can't tell if the order is switched.
Yeah.
Because they're similar movies. So I have to take this and divide it out.
Okay.
You follow what I'm saying, Morgan?
Yeah, I do.
Okay? So I go 18 factorial over 6 factorial, 6 factorial, 6
So I
factorial.
do a calculator just like that, I get that. You don't have to put brackets around to get the exact same.
Yeah, and I factored it out, like I went 18 times 17 times 16. And then I just put the ones.
What's the answer?
No, sure. I get 17,153,136.
Yep, how'd you do it? 'Cause I think I'm doing it.
Magic.
This is-
This is what I put in front of.
Just have to factor
It's
out
like
each
I do
individual
that,
one.
Think about it.
Yeah, I just.
I understand.
12 divided by 4 times 2. You went 12 divided by 4 and times it by 2, which is 6.
See,
Instead of 12 divided by 8.
The English test got me.
You need brackets. Anytime you have multiplication on the bottom, you have to have brackets. Okay? All right, Morgan, you better?
Yeah, I'm better. I just don't feel any smarter. I feel, no, I am smarter because I learned that, but I don't feel like, I feel like I asked a dumb question.
You didn't ask a dumb question. You're not the only one that's having these issues. That's the thing. You're saying exactly what everybody else is thinking. Okay?
Can we do the next question, number 7?
Sure.
I had 0 clues what to do other than,
In a set of n objects, there is one subset of 3 identical objects and the rest are all different. Investigate a pattern in the number of arrangements of these n objects. Make a statement about the pattern as n increases. So the number of objects is 3, the number of arrangements is 1 arrangement. 4 and then what? How many arrangements are there? Okay, this is a silly question. Here, I'm going to make it make sense to you. All right, this is how this works. I have 5 letters. I'm going to arrange 5 letters. So how many ways can I arrange 5 letters?
5 ways.
No, it's not 5 ways, Morgan. It's 5 factorial ways.
Okay.
Okay? Because you've got choice of 5, a choice of 4, 3, 2, and 1, all right? So that's 6, what is that, 120, right? Okay? So there's 120 ways I can arrange those 5 letters.
Okay.
All right? Now what this guy is saying is these 3 guys, I want them all to be together. I want A, B, and C to be together, and D and E can be wherever they want. Okay, you following me?
Mm-hmm.
All right. So, if these 3 guys got to sit together, I change the way I approach this. How many groups do I have now? How many decisions do I get
3
to make?
factorial.
That's right. That's absolutely right.
I gotta speak Mathanese. Instead, can't
Okay.
say 5 decisions, gotta be 5
Because-
factorial.
So this guy is going to be A, B, C, right?
Yep.
Let's say. And then this would be D and this would be E. Something like that. But you have a choice of this group, or this group for that one. And then if you pick one, you have a choice of the other 2 for this, and you end up with 6. So that's right. But I also have to take into account the number of ways, and I need everybody listening here because this is new to you. You haven't seen this yet. I also have to take into account the number of ways I can arrange A, B, and C. All right, because it could, so if I'm lining these up, and A, B, and C have to be together. So let's make this D and E. So this could be A, C, B, right? Could be A, B, C. Could be B, C, A. So I have to take into account how many ways I arrange these. The long and short of it is this. This is new. Make a note of this, please. The number of groups, factorial, times the number in each group. Factorial. So when you're grouping together, now this is where it gets confusing for lots of students. This is not the same as like permutations. This is actually grouping some together and then finding how many ways in which you can arrange them. Okay? So go back to here. My original question was, how many ways can I arrange 5 letters? Well, it's 5 factorial. My next question is, well, what if A, B, and C have to sit together? What if those 3 have to be together? So then I make them one group. So now if I group A, B, and C together, and I have D and E by themselves, how many groups do I have now? I have 3 groups then. A, B, C is a group, D is a group, and E is a group. So I go 3 factorial here. Now I multiply it by in each group because I also have to take into account the ways in which I can arrange A, B, and C. A, B, C, A, C, B, right? B, A, C. So I have to take that into account. So how many are in that group? There's 3 in that group. How many are in the group with D? 1. And the group with E? 1. I don't have to write in 1 factorial for the record. But I'm just showing you this is how I get this. So this is what we call a group permutation. So in a group permutation, you take the number of groups, factorial, times the number in each group, factorial. So in this case, I'd have 3 factorial by 3 factorial, which would be 36 ways in which you can do this question. Okay? This is new. We haven't talked about this. We didn't talk about it last week. That needs to be on your cheat sheet as well. You need to make sure that you put that on. So to answer your question about 7, I don't really care if you can do it, but if you have a group of 3, there's only 1 group. If you have 4 objects, there's 2 groups. There's a group of 3 and 1 extra group. Right? If you have 5, you have 3 groups. A group of 3, a group of 1, and a group of 1. If you have 6, you have 4 groups. A group of 3, a group of 1, a group of 1, and a group of 1. You see the pattern on there?
Yeah, good thing I asked you, because I would just start guessing. Just start putting 2, 3, 4, 5, 6, 7, whatever, and just guess that that's how the pattern works.
Yeah.
I need to know what, because
So
then the second question is more in depth.
Yeah.
So if I don't know what I'm doing, then my guessing will be obsolete.
So in other words, if you were to look at that second part there, if you had 6 objects, that's a group of 3 and 4 singles. Single groups.
Sorry, could you put a group of 3 and 2 groups of doubles?
Mhm.
That would change your answer.
Mhm.
So then the answer technically for bottom would vary, right?
Yes.
Because even if you have 6, you could have 3 groups.
Yes. Okay.
They don't have to be even, equal.
Yeah. I don't need you to focus on that question on 7, A and B. I need you to know this right here.
Okay.
That'll help you solve the questions based on that.
And there's 2
So-
3s there because, 2, 3 factorials.
Because the number of groups, 1, 2, 3, that's the number of groups. The number in each group, well, how many are in this group?
3.
3, and then 1 and 1. There's your 1 and your 1.
Oh, okay, so the 3 and the 2 ones are separate because they're the group.
Yes, that's correct.
You got numbers in each group, yeah.
Okay?
Okay.
All right. I'm not sure where there's another example of that question, but probably in the review at the end. Okay. Any other from 4.4 and 4.5?
I think I have one from 4.3, number 9.
Page?
Chapter 9.
Number 9, you said?
Yeah, I think it's easy. I think I'm just making a sticky.
Neil's created an 8-character password. More than half of the characters will be upper or lowercase letters, and the rest will be digits from 0 to 9. Neil will use at least one digit and will not use any character more than once. The digits will follow terms. Okay, describe 3 different cases for this problem. All right, so start with that. You need an 8-character password. More than half of the characters will be upper or lowercase letters. So what are all your possibilities here?
Well, is it like 26, 25?
No, not yet. You're not there yet.
Okay.
That's the next part. What are all your possibilities?
No.
So, like, 4 letters, 4 numbers, 5 letters, 3 numbers, right? Those are your possibilities. So what are they? Letters, numbers. What are your 3 possibilities?
More than half the characters will be uppercase.
No.
No, at least half of the letters, half of the numbers.
So it's 4 and 4?
No. More than half of the characters will be letters.
Oh, so it'd be 5 and 3.
5 and 3,
5 and 3.
6 and 2,
1 and 7.
7 and 1, and you have to have at least one numerical digit.
Yeah.
Okay?
I see.
So now, because I cannot use my number again, this has to be a permutation. Okay? So if I were to draw out the first one, my selections, 5, right? 26, 25, 24, 23, 22. And then I need 3 single-digit ones.
9.
10, 9, 8. Again, you got to use 0 as your 10th. 0 as your 10th number. So that would be, there's case number 1. Or, you can do that too. Again, because it says I cannot use the value or the digits or the letters a second time, I need a permutation here.
So how'd you get to 26?
26 letters in the alphabet.
Yeah, you have to pick 5 of them. Yeah. And there's 10 letters.
So what's the next case going to be?
P6.
26P6, 10P2,
Then what's
26P7, 10P1, and then add them together. Go ahead.
what's the big difference between C and P?
Order is important in P, permutations.
Okay.
Okay? Now, so they'll state it by saying positions, they'll state it by giving you, saying you want the first, second, third place person in a race. In this case, it's a permutation because I can't use, I'm looking for order. It's asking for a password, right? So a combination of a password. We had this discussion about the combination lock. What should be a permutation lock? Because the order is important in what you're selecting. Okay? So because it specifies that, then we know it's a permutation. Okay? All right, any other questions today? Petra, go ahead.
Oh, I actually.
All right. So permutation, Petra. N factorial over n minus r. Oh, that's an n. That was r. Agreed? What's my n in this case? Is that 5 right there? What is it? Say again? Look at the question. What's in this position on the P? Pardon me?
minus
Just minus 1?
and minus one.
And minus 1. Yes? Okay, so I have n minus 1 factorial right there. That's your top part. So now I have, on the bottom, I have this, which is n minus 1, subtract 2. And is that, or is that? So far, so good? So I have n minus 1 factorial. It's winning. It's winning. There. Perfections. Which one's larger, n minus 1 factorial or n minus 3 factorial?
And minus one is larger.
N minus 1 is larger?
Yes.
Okay, so let's expand that one out then. So to expand it out, I have n minus 1 times n minus 2 times n minus 3 factorial over n minus 3 factorial equals 12. I'm going to be honest with you. In this class, I'm going to tell you, if you don't know what to do, put numbers in. Plug your numbers in. See what you get. Like you could put them in right here and do it.
That's how I did it, because like
But-
I remember counting.
In pre-calculus, you cannot do that. You have to take it out because they're looking for the algebraic part of this. So now, what is this saying? Go ahead. What is this saying? If I have this, I repeated this twice last week. Somebody tell me again in my own words, what does that mean? It is that, yes. But what is it saying? What am I looking for here?
1 minus 1 is 0, and 2 minus 2 is like you're trying to solve
No.
for n.
You're
No.
trying to find a common value that would make the answer true. Like that.
Okay, that's a start. Well, give me the numbers.
Oh, 7 minus 1 and I'm just kidding. Thinking out loud.
That's fine. Think of a lot is fine. That's okay.
Can I make a guess? This is n for, no. Oh, never mind.
This question is far simpler than what you are doing.
Can I not just do it out? Just find n?
What is it? What is n?
2?
You would have to factor it
But
out. and
don't
then
you solve,
find
like,
n. You would have to-
What times what subtract what? You take like 7 subtract 1 is 6, and then 2, so 6
And have
times
to
2
be the
is
same
12.
number.
So 4 subtract 2 is 2, and then
You
6
started good,
This arrow.
Started
It'll
well.
have to be the same number.
and it has to be the same
Yeah,
number,
that's
yes.
why I'm. So can you FOIL those, and then you do algebraically, do not?
Minus 10. Then it's factor.
So you get n squared n
Okay,
minus.
no, you guys are you're ahead of the game right now. Seth,
N is 5.
n is 5, Seth. Brilliant, how did you get 5?
Because 5 take away 2 is 3, 5 take 1 is 4, 4 times 3 is 12.
Seth wins.
Yeah.
First time in 3 years he said a word in this class and he wins. Well done, man. Well done. I like it. What does this mean? It means what are two numbers that are consecutive that you multiply to give you 12?
12.
Well, what are those two numbers? 4 times 3 is 12. So then what does n have to be, Seth? 5. 5. 5 subtract 1 is 4, 5 subtract 2 is 3, 4 times 3 is 12. Seth nailed it. Okay, now, that's fine. You can plug numbers in. That's okay, I don't mind that. How do I solve it? Factor, exactly what you were saying. N squared minus 3n plus 2 equals 12. N squared minus 3n minus 10 equals 0. Right? N minus 5, n add 2 equals 0. N equals 5 and negative 2. You can't have anything less than 1. The answer is 5. So, you do all this because that's the way your brain thinks. Excellent. Trial and error this, no problem. I could have trialed and errored right here as well. I could have just stuck in a number here until I got to 12 and used my calculator. Now you should show what you're doing. So if you're putting in 6 and you got 5p2, then write down 5p2 equals whatever it is. 20. Didn't work. Then I put it, yeah, that's okay. Applied allows that. All right? That's fine. But what I need you to do, because you're going to get a question in which you're going to have n minus 1, n plus 1, and n minus 2, and you multiply them all together and you get a number like 720, you're not going to be able to do that using the algebra. You actually have to trial and error it. You have to find out what are 4 consecutive numbers that I multiply to get that number. So you plug numbers in until you get the right answer. Okay? All right? Okay. You got the rest of today to get going. We should be planning on a test likely Thursday. So we're going to see where this is at. You should have been done to the end of 4 or 5 today. That was signed for Friday. So, yeah. Okay.
Signed it?
I can't remember.
I go to Washington.
Okay.